Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, where I've been doing a feature on the Math Lovers book. This is a three-volume series I wrote from 2019 to 2022 that's available on Amazon.com, both in paperback and in Kindle. And I'm now starting a new section. I'm starting section 2.8, volume 1, which is on number tricks. And the first of those number tricks I'm going to talk about is casting out nines, which is a very useful number trick. So anyway, let's begin. So like I said, I'm starting a new section on number tricks, and now I'm going to describe this trick called casting out nines. You might have heard of it. It's a very useful trick. It's basically a trick for dividing really big numbers by 9, or finding the remainder, actually not dividing by 9, but finding the remainder upon division by 9. There's what's called the digital root of a number. Yeah, and that's just, it's almost the remainder when you divide by 9, not quite. Because if the number is divisible by 9, we say the digital root is 9. And the way you get the digital root of a number is you just add up its digits, and then you take that new number, and then if that number is bigger than 9, you keep adding the digits of that new number. Keep going like that until you get a number that's between 1 and 9, and that's what's called the digital root. And it turns out that the digital root is equal to the remainder of the number after you divide it by 9. Except, like I said, it's equal to 9 if the number is divisible by 9. So this not only tells you which positive integers are divisible by 9, and you can start with some really huge numbers, but it also tells you the remainder if you divide it by 9. So I give an example on this slide. I think it's kind of a small example. The example I think I give is, oh yeah, actually I do 314159265 This is 3,141,592,693. It's a number of the billions, and in case you want to know where I got the digits, they're just the first 10 digits in the decimal expansion of pi, which I happen to know at 100 digits. But anyway, I've got a short video on casting out nines in case guys want to watch that one. I have a few short math videos, and this one I think is less than a minute as they have to be, and I think I give this example, and I think I give an even bigger example. But anyway, suppose we started with this number, this really big number. Let's say it again: 3,141,592,653. Suppose we want to know whether or not that number is divisible by 9, and if it isn't, what's the remainder if you divide it by 9? Well, like I said, what we do is you add up the digits. So you take 3 plus 1 plus 4 plus 1 plus 5 plus 9 plus 2 plus 6 plus 5 plus 3. If you do that in addition, which I think you can do in your head, you get 39. And then you do the same thing with 39. 3 plus 9 is 12. So we're still not less than 9. So we have to do one more time. 1 plus 2 is 3. That means the digital root of the number we started with is 3. That means if we divided this number by 9, the remainder you get would be 3. Pretty amazing. And you might wonder why this trick works. I explain it in this next slide. Um, Basically, the idea is that this works because 9 is 1 less than 10, and 10 is the base we work in. If we were working in a different base, then the same trick would work for casting out b minus 1. If our base was b, the same trick would work for casting out b minus 1. For instance, if we were using base 12, which is, a pretty popular proposed alternative to base 10, then this trick would work for casting out 11 or casting out a, because a is the symbol we use for 11, or actually it's b. It would be casting out b. But anyway, the idea is, let's just give you an example. I'm going to try to convince you why this trick works. So suppose we have a 4-digit number. It's easy to start with a specific example. I'm not going to give a specific number. I'm just going to say the digits are A, B, C, and D. So we have a number we would write out as A, B, C, D, where the A, B, C, and D are just digits, where A is bigger than 0, but the other digits can be anything. The A can be 1 through 9. So, for instance, 7,546. The number itself isn't really important, but let's just see what happens. So what I'm going to try to convince you is that the remainder upon division of the digital root of this number, which is A plus B plus C plus D, is the same as the remainder of the original number we start with when we divide by 9. Why is that true? Well, let's look at each digit individually. Um, I mean, A represents 8 times 1,000 in the number we started with. B represents B times 100, and C represents C times 10. So our number we started with is really 1,000A plus 100B plus 10C plus D. Well, it turns out that every power of 10, its digital root is 1. And it's also true that the remainder upon division by 9 is 1 for every power 10. And that's kind of easy to see because if you have 1,000 minus 1, that's 999. And that's 111 times 9. And similarly, 100 minus 1 is 99. That's 11 times 9. And, 10 is 1 more than 9. So I think you get the idea. If you started with any power of 10 and subtract 1, you're going to get what's called a rep digit. You're going to get a number with all its digits equal to 9. And that's pretty easy to see that that's divisible by 9, because when you divide that number by 9, you just get all ones. So that's why this trick works, because the digital root of every digit is just that digit. I mean, that digit times any power of 10, in particular the power of 10 we're using to multiply by when we construct our original number. So, and also digital roots are additive. I mean, remainder is additive. So, for instance, the remainder of A, B, C, D when you divide by 9 is really just the remainder of 1,000A plus 100B plus 10C plus D. But that's the same as the remainder of 1,000A plus the remainder of 100B plus the remainder of 10C plus the remainder of D. Of course, you still have to take that sum mod 9. You might have to do this in several steps. But I think you get the idea. This is why casting out 9s works. And it's a very useful trick, and I think you can impress your friends with this trick. And it has some practical applications as well. But mostly it's, if you want to impress your friends at a party, show them how smart you are. Maybe they don't know the casting out times trick. Tell them to give you a really huge number. Tell them you can find the remainder when you divide it by 9, and then they can check on their calculator. They can subtract the number you give them and divide that result by 9, and they'll find that gives you an exact integer. So that's a pretty useful trick. And that concludes my video for today on casting out 9s. So thank you for watching. Long live math, and I'll see you guys next time. Bye.